And so the time has come for the dreaded story problems. Oh, I know you thought you'd had them already, but no. They were just beginning. Okay, so this section is chock-a-block full of story problems. And then the story problems that are kind of more traditional to algebra courses. And the reason they're traditional is because, well, they're really darn useful. I know you probably don't want to hear that, but being able to figure out value, interest, and mixture problems is really important, especially for other courses, honestly. These are the kind of problems that you need in chemistry classes and in science classes. Interest problems are for business classes and finances and stuff like that. So these are important ideas, and we are going to do them much to your dismay. So let's read through the 5-step problem-solving method. To solve some problems in which we want to find two quantities, it is useful to perform the following 5 steps. 1. Define each variable. And we've been doing that all along anyway. I mean, for every quantity that we are trying to find, we usually define a variable to be that unknown quantity. But we do more than that. We kind of set up, a couple different variables. We give them appropriate letters. We make sure that we know which one's independent, which one's dependent. There's a lot going on in there, right? Then we want to write a system of 2 equations. We're going to write 2 equations that relate the 2 variables. And just a little tip about algebra, it's called the fundamental theorem of algebra. If you have 2 unknown things, you're going to need 2 equations. If you have 3 unknown things, you would need 3 equations, and so on. But we will never get more than 2 in this algebra class. We can usually write both equations either by translating into mathematics the information stated in the problem or by making a substitution into a formula of some kind, like distance equals rate times time. That's a classic. All right, then we're going to solve the system. So once we have the system, then we're going to solve it using elimination, substitution, something like that. And we're going to describe what we see using a complete sentence to find the found quantities. And then we just want to check and make sure that everything that we found makes sense. All right. So in theory, it sounds like a great idea. Let's see how it works. Now, the one thing, they have a little formula in here, and this is there's 3 types that we're going to be learning. So type 1 is a value problem, which is, I got a couple of them in here, and then interest problems like annual interest rates, like on a credit card, and then another interest rate problem that I put in there, and then mixture problems like you need in science class. I have a 10% saline solution and a 20% saline solution, that kind of thing. All right, so we're going to start off with value problems. Now remember that if you have n objects that each have a value v, then their total value t is given by t is equal to v times n, which is a fancy math way of saying, look, if I'm going to buy 20, kumquats, and they each cost $10, 20 times 10 makes $200, right? And that's your total cost. I mean, everybody kind of knows that inherently. That's what this is talking about. All right, so let's read through this problem here. We have an auditorium. It has 900 balcony seats and 3,500 main level seats. If tickets for balcony seats will cost $20 less than tickets for main level seats, what should the prices be for each type of ticket so that the total revenue for a sellout performance will be $149,200? Oh, there's a lot going on. Okay, so hold on. There, let's make some tables here. All right, so step 1, we need to define some variables here, and we need to define them quick. So let's read through this again and try to figure out what it is we're looking at here. We have an auditorium. It has 900 balcony seats and 3,500 main level seats. If the tickets for the balcony seats will cost $20 less per ticket, less than the tickets for main level seats, what should the prices be for each type? There it is right there. What should the prices be for each type of ticket? See that? So there's 2 tickets, right? There's main level seat tickets and there's balcony seats. So we're going to make 2 variables. So we're going to let x, x equal the cost of, let's say, main level seats, and y be the cost of balcony seats, right? And again, the order there doesn't really matter. I mean, it's not like it makes any difference which one you made X and which one you made Y, but you need balcony and main level. All right, now that we know which one's which, and in this case, it won't really matter which one's independent, dependent. It doesn't make any difference because we're not going to be working with that type of problem. So we don't care so much as we have in the past for, say, the linear regression problems where you have the tables and stuff. All right, so now that we have our variables, we need to write a system of two equations. All right, what that means is we're going to need two equations. So we need two things about x and y that we know. Okay, so there's two things going on here. You've got the money, right? How much they're costing. How much will the prices be? So this is the price or cost. It doesn't really matter of each one. So there's that aspect to it. And then there's this other aspect of how many each kind of seat there are, right? So that's going to help us as well. All right, so let's read this one sentence right here. It says, if tickets for the balcony seats, see that? Tickets for balcony seats will cost less than tickets for main level seats, $20 less, right there. That phrase is giving you one of the equations. It's telling you that, hey, your tickets for your your balcony will be equal to $20 less than your tickets for the main level. So that's x minus 20. Now, you always want to kind of figure this out in your head. Like, okay, if they're charging $50 for main level, that would be going in for x, right? 50 minus 20 makes 30 for the balcony, right? That would work. Because if this number was 50 here for x, then this would be 30 here for y, and that would make sense. Because everybody always gets confused. Is it 20 minus x? Is it x minus 20? So it's $20 less than. Less than means you're going to flip the order. So you're going to go x minus 20. All right, so that one came from that guy. Okay. Oops, I don't want to do it that way. All right, then the other phrase, there. The other bit of information you need is, well, it's a little bit harder to spot. It says that there's 900 and 3,500. All right, so 900 balcony seats, 3,500 main level seats. So that seems kind of important. But 900 and 3,500 isn't really a question that was asked. It wasn't saying like how many seats are there. We know how many seats there are, so that wasn't the problem. The deal is that x and y are price, and the 900 and 3,500 aren't really prices. Except down here it says a sellout performance will be 149,200. See that? Now together, those two pieces, even though they're separated by a couple sentences, actually one sentence, just means that you have, let me see, I have 3,500 main level seats plus 900 balcony seats equals 149,200, because I have 3,500 seats sold at however much I charge those people. Then I have 900 seats sold at however much I charge those people. And together that has to make $149,200. In other words, this is a money equation, right? So this one's setting up a direct money equation, and the other one's setting up more of like a grand total of money. So this is, here, let me label them for you. So the green one's more there we go. How the two types of seat prices relate to each other. And then the second one is how, there we go. It's the total money for a sold out concert, right? So there are two different kinds of things going on here. And you had to piece them together, and it's not going to be obvious all the time, but you've got to figure out a way to make it so that each of the two variables relates to each other twice. You've got to figure out one connection between main level price and balcony price, and you got to figure out another connection between them. And that was what that 149,200 was making. All right, that's the hard part, step 2. Once you have these two equations, then you have to solve them in step 3. But solving them isn't really that tricky, because what you'll do is you'll either do it by substitution or elimination. However, hopefully you recognize that in this one, elimination is not really a sensible option, right? Because you have it so that y is already solved, right? So instead of writing y in that bottom equation, you can write x minus 20. You can substitute right away. Instead of writing 3,500x plus 900y, you could write 3,500x plus 900 times x minus 20, right? Because that's what we said y was equal to. And then solve this for x. Totally solvable. Okay, so this will be 3,500x plus 900x minus 1,800. Oops, 18,000, sorry, equals 149,200. Okay, so that gives us 4,400x minus 18,000 equals 149,200. Then we just got to add 1,800 to both sides. Or 18,000. I keep saying that wrong. Sorry. And then let's see what we've got. Over on the right, we'll have, or over on the left, excuse me, we'll have 4,400x is equal to, let's see, 167,200, I think. Yeah, that works. All right, and then we divide both sides by 4,400. And use a calculator, right? And you're going to find x is 38. And now, of course, this is $38, right? Right. Once you know what x is, let's see when we're done. So we solved that equation. So we solve, but we haven't solved the system yet. So we're not really done with step 3, because solving a system means finding both x and y. So we found that x was 38. Now we need to go find y. So remember, we said y was equal to x minus 20. Right, that was one of our equations. So all we have to do is put 38 in there for x, and we'll have it. We'll have it, oh, it's 18, right? Dollars. Actually, you know what? I'll do at this stage. I won't even put the dollar signs in. I'm just going to leave them 38 and 18, just for the sake of our sanity, okay? So all we did was find the two number solutions. So we found the x and we found the y. Now, step 4, you have to actually put it in back in the context. You say, you know, okay, I found the answers. They were 38 and 18. So that means that we're charging, oops, and we have to do it in complete sentences as always. We are charging $38 for main level seats and $18 for balcony seats. Cool. Step 5, you just kind of do a check. You know, does this make sense? If you put in, you know, 38 and 18, would this work? So you can always double check it with a calculator or something. Take the two numbers, put them in the other equation, see if it'll work, you know, see if it works out. Actually, if you put them in the equations, chances are you're going to be right. So just kind of see to yourself, does this make sense? You know, if I did 900 tickets at that one price at $18 and 3,500 tickets at that other price, right, would this work? Right? And the answer is yes, sure. Right? 3,500 times, let's see, 38 plus 900 times 18. You can check it with a calculator. Quit. 3,500 times 38 plus 18 times 900. Yep, it works out just like we thought. Cool. So the answer makes sense, which is what we were really looking for, right? Does this really work out? All right, we're all done with that one. Now notice steps 3, 4, and 5 are actually not hard. It's step 2 that is just the killer, right? Because you really got to figure out two equations. That's the hard part. Once you've got them, it's not bad. Okay, well, we were going to take our time and do the next one in the next video. So I'll see you back here then.